each time, and each time you see that this rifleman is firing the bullet. The bullets are found out at a particular position, but not at the precise position. Then we can say it is precise but not accurate. But when the bullet is fired, when the bullet is at a different position, then we can say it is neither precise and nor accurate. So you may have an example also to explain this. Then we go to reporting of results or chemical expression of results. See, in chemistry, we are measuring the results for different substances, like for solids, for liquids, and for gases. So in case of solid, the weight percentage is calculated. And do you know what is weight percentage? Simply weight of constituent element or constituent by weight of sample into 100. So weight percentage means weight of constituent into 100 by weight of sample. It is expressed in the same way as in solid. So weight volume percentage, same thing again, weight of constituent by volume of the sample into 100. Remember, when we are writing volume, then it is in milliliter. Writing in weight means it is in gram. So weight of constituent by volume of the sample into 100 will give you weight volume percentage. Similarly, one more thing is the volume percentage, means volume of constituent by volume of sample into 100. Volume of constituent by volume of sample into 100. Next one is for gases. For gases, it is mainly expressed by volume. So volume of constituent by volume of sample into 100. Because gas is only measuring volume. So we have no other way to measure the weight. So only we can measure volume. So volume of constituent by volume of sample into 100 will give you the percentage by volume of the gas. Students, can you take 1 minute break? Akarsan? Okay.
Okay, sir.
Okay. 1 minute break, okay? Okay. Again, we will continue. The next one is significant figures. Significant figures means, remember that a figure or a digit in any of the characters 0 to 1, 0, 1, 2, 3, 9, which alone in combination serves to express a number. The digits of a number which are needed to express the precision of the measurements from which the number were derived are known as significant figures. So significant figure means the digits of the number which are needed to express the precision of the measurement from which the number was derived are known as significant figures. Then there is a method to calculate the significant figure also. The rounding of methods is there. We are going to discuss this one. Yes. Then now we will discuss the important one is the evolution of analytical number 2. Unit 2, 3, I am discussing it now. In Unit 3, the important terms called mean, median, mode. Mean, median, mode. The mean is the most widely used measure of the central value. Mean is the most widely used measure of the central value. For a finite sample, mean means for example, you have 5 experiments. So in each experiment, you have a value x1, x2, x3 up to x5. Then you can add x1 plus x2 plus x3 plus x4 plus x5 by 5. Means number of observations means the number of values in each observation. For example, you have 5 observations, then add x1 plus x2 plus x3 plus up to xn by n. This is give the mean value. And x1, x2, xn are the replicate observations. And the mean value is calculated by adding all these values and by dividing the number of observations. Next one is the median. What is median? What is median? The median. Median means what? Median means, for example, median means the middle value. There are equal number of results and there are larger or smaller than the median. For an odd number of observations, median is simply the middle value. For example, you have 11 observations, then sixth observation value is the median value. For example, you have but if you have 12 observations, then the sixth and seventh value observations you have to add and calculate the mean of it, then it is called as the median. So for odd numbers, you have no problem. For a set of even numbers, total observation if n is even, then the median is the average of the middle pair of observations. For example, you have observations like 1, 2, 3, 4, 5, 6. Then the two middle values are 1, 2, 5, 6. You simply discard. It is 3 and 4. So 3 plus 4 by 2. Then 7 by 2 is equal to 3.5. So 3.5 is the median value. 3.5 is the median value. Okay. So now, hello. So therefore, median value is used advantageously when a set of analytical data contains a probable outlying results. So median is calculated very simple. If n is odd, then the middle value is the median. But when n is even, then the two middle value you have to know. This two middle value you have to find the average. If that two middle value is 3 plus 4, then you have to add 3 plus 4 by 2, 3.5. This is the median. But for odd, it is no problem. Simple, the middle value will be the median. Next one is your mode. What is mode? For example, a set of numbers. Remember, the observations which occur most frequently in a series of observations is called as the mode. For example, if I will say 1 1, 2 2 2, 3 3 3, 4, 5 5 5 5 5. So 5 I have repeated 5 times. The observations which occur most frequently is called as the mode. So mode means the observations which occur most frequently is called as a mode. Then there is called standard deviation. So in case of standard deviation, the values are measured like a formula is there. The deviation formula sigma equal to. Okay, what do you mean by standard deviation? It is the most important statistics to indicate the precision of an analysis. According to the International Union of Pure Applied IPSC, sigma is used for population of the standard deviation, and the symbol is used for sample standard deviation. Sigma is equal to root over of d1 square plus d2 square plus d3 square of dn square by n. By n. This is called sigma. And d1, d2, d3, these are the individual deviations. And individual deviations. Okay. Some examples are given. For example, I can cite an example here. The example is there are 4 experiments. Then you can calculate the average of it simply by using this value sigma. Sigma is equal to d1 square plus d2 square plus dn square by n. Okay. Okay, next one is relative standard deviation or RSD. RSD equal to S by X bar, where X bar is your value of deviation and S is the actual standard deviation. So standard deviation in relation in relative term rather than an absolute term. In doing so, we can get a clear picture of the data quality and compare to that by absolute conditions. So remember, the relative standard deviation is calculated by dividing the standard deviation by mean value of the analytical data. The important one, it is calculated by dividing the standard deviation by mean value of the analytical. So you divide standard deviation by analytical. It is often denoted by the symbol SR and can also be expressed in suitable units as desired. CB is equal to S by X into 1000. MCB is called as the coefficient of variation. So remember, when I am discussing about coefficient of variation, it is simply when I am discussing about coefficient of variation, it is simply I am discussing about the standard deviation by X. X means mean value into 100. So remember, the two things are different. The two things are different. One is called as the relative standard deviation, and second one is called as the coefficient of variation. So coefficient of variation is the definition is the standard deviation by mean value into 100. The next one is Gaussian distribution of data. Gaussian, Gaussian distribution of data. As we know, precision of a given set of measurements can be ascertained from the value of standard deviation. However, this term does not indicate how the replicate results are distributed. Probability distributions are of fundamental importance in the use of statistics for judging the reliability of the analytical data. The word error is used somewhat loosely while taking for interdeterminate errors. Since strictly we should speak about deviation. See, now what do you mean by deviation? Deviation means whatever the value you are getting from an instrument measuring it and the standard value, they are not matching. This is called deviation. So all measurements contain random. So therefore, I'm telling you all measurements have deviations or they can have random errors. The elimination of these errors is beyond the power of the observer. So we cannot able to eliminate everything. However, an analyst can estimate the uncertainty introduced by random errors. We can apply the laws of probability provided we have sufficient number of observations. These laws are probability or rules of chances in an empirical way. We are measuring the knowledge. So Gaussian distribution of data is nothing but a plotting of the normal error versus. So you can take normal versus the relative frequency. So remember always the graph is drawn between relative frequency and deviation from mean. How much deviation is obtained from the mean and the relative frequency. Then you can have a curve like heap-like curve, and the highest point it indicates that the deviation is not at all. There is no deviation at the highest point, but the highest deviation is the least point. Then that's the probability distribution. This for a probability distribution of random errors. A distribution of random errors follows the normal frequency curve called Gauss and can be expressed by a differential equation dn by n is equal to 1 by sigma root 2 pi exponential term minus 1 by 2 x minus u by sigma the whole square dx. So this dn by n is a fraction of molecules having highest errors. The next one is called confidential interval. So the above discussion, see, you understand that the mostly in chemical analysis, the true values of the population means, see, these are some analytical methods. Whenever I am discussing about analytical methods, remember that these are very much mathematical things I am discussing it. It is not at all chemistry. It is an analytical tool. So therefore, no chemistry there in your first unit 1, unit 2 or unit 3. Because these are all basing on what? Basing on the computational means from the instrument, the data you are getting is called analytical methods. I mean data you are receiving from the instrument, and the data you are analyzing it. Therefore, it is not easy to teach this thing because it is an analytical method. You can only when you are doing some experiment and getting some result, these values are you are interpreting the values. This is called analytical methods. Remember always, I have discussed about the analytical tools. Okay. Then one more thing, criteria for rejecting of data. Sometimes in a set of analytical data, there appears a value which is not fitting in the set, and it looks at a wide difference from the rest of the values. Now the question arises how to decide whether to remove out a result which appears out of lines with other when there is no known reasons to suspect it. The question is not at all important. The important is when you are rejecting a data, then the data must be uh, absolute. Means, for example, whenever you are doing an experiment and you are getting a value which is very far away from your imagination, then this value can be rejected. So, the criteria for rejection of an observation are based on the supposition that an outlier is due to some systematic source of error. It means error can be only neglected when it is far from our imagination. Hence, it is called a rejection of data. So, rejection of data involves simply removing this value, or that value you can ignore it because the value is very much far away from your original value. So then students will discuss one more thing because half an hour is left to discuss one more thing. Is the in unit 2, I have left one thing. There is the system significant figures. That one I will discuss in details because I've told that the significant figures you get some questions. Um, okay, consider a number 107.2. Consider number 107.2. The zero between 1 and 7 is significant. Remember, when the zero is present between two non-zero digits, the zero is significant. So 0 between 1 and 7 is significant because 0 placed between two significant figures is significant. If a 0 is placed between two significant figures, then 0 is said to be significant. This number has four significant figures because 1 is 1, then 0, then 7, then zero point 0.2. I'm discussing about a figure, a number 107.2. You have to calculate how many significant figures are there in this number. So when I'm writing it 107.2, remember that here 0 is in between 1, 0, 1 and 7. So if any 0 is present between two non-zero digits, the 0 will be counted. So here it is 1, 0, 7 and 2. So four digits or four figures are there. The number of significant figures equal to 4. Uh, Similarly, if I will say, if I will say a value is now 1072, then you have also four significant figures because 1, 0, 7, and 2. If it is 10.72, then also four significant figures. If it is 1.072, then it is also four significant figures. But if it is 0.001072, 0.001072, then you have also four significant figures. But the first two zeros are not counted because it is not in between the two significant figures. If two non-zero digits are there and zero is in between this, then you have this zero will be counted to have significant figures. Okay? Okay. Students, for a break of 1 minute. Gulnaj, Rohini.
Okay, sir. Okay.
Yes, Rohini, can we take a break of 1 minute?
Okay, sir. Okay.
Should we continue? Significant figures. Should we continue now?
Yes, sir.
Yes, sir.
Okay. So now next one is, for example, we'll do one more example. That for example, the value is 22.6. For example, you measured a volume 22.6, and you have simply a change in the uncertainty is plus minus 1. Plus minus 1. That means plus minus 1 means it is 22.6 plus minus 1 means you add plus 1 and minus plus 1 minus 1. So the value will be in between 22.5 and 22.7. So remember, a value of 22.5 and 22.7 is because the value 22.6 is the real value, but there is a precision of uncertainty of plus minus 1. So you add plus 1 and you minus also subtract plus 1. So 22.5 and 22.7. This is the observed uncertainty between the two numbers. In rounding up the quantities to desired number of significant figures by dropping the superfluous figures. So remember, when a figure is written, for example, is 46.2368, then you have to round it up to four significant figures. Understand? Uh, so whenever you are rounding a particular figure 46.2368, it has six significant figures, but you have been told to make it four significant figures. Then the last one, the last figure, you see 2368. So 8 will be dropped. 6 is there. 6 is more than 5. If it is 6 is more than 5, then we have to add 1. So 2, 2, 3, it becomes 2, 4. The result will be 46.24. So the value 46.2368 will be rounded to 46.24. So if the drop digit is exactly 5, then it will be treated as a greater than 5. It is 5 or less than 5. If it is directly 5, then it will be simply added 1. For example, 3.55 is rounded to two significant figures as 3.6. So last 5 will be, if it is 5 or more than 5, then you can add 1. So 5 plus 1 equal to 6. The value will be 3.6. Similarly, if it is 3.65, rather to two significant figures, then this 5 will be only removed and the value will be 3.6. So if it is 5, 5, then 5 becomes 6. If it is 6, 5, then it will be only 6. Then in addition or subtraction, two significant figures can be added or can be subtracted. The subtraction or addition of significant figure is the answer is rounded up to the significant figures in terms of least significant units. It is mainly for decimal places in the numbers, and the number of having fewest decimals is just the least significant unit. Okay. Next one is your next one is last portion. Last 15 minutes left, so we'll discuss about the uh, emerging needs and recent trends. Emerging needs and recent trends. Remember, analytical chemistry is of the fundamental importance as it is based on the development of methods for identification, determination, and separation of substances in different ranges. Hmm. Identification of new compounds and its structure elucidation. For example, need the result of the chemical analysis for its confirmation. So, analytical chemistry is nothing but the study of chemical analysis for its confirmation. For example, a new compound you have synthesized. Whether the new compound you have synthesized is a what you have discovered or what you have uh, analyzed or not. So to know it, you have to do various tests. So various tests will tell you about the various properties of this organic or this compound. And if it is matching, then you can say, okay, this is the new compound sorted. So tests is very important. Nowadays, the chemical analysis in industry is very important. You know that during coronavirus also, many important observations or many important research has been done. And because of research, you have found out a new coronavirus medicine also. That is because of the testing of various chemical compounds through, through these analytical methods. So analytical chemistry is recognized to fulfill both the fundamental as well as the applied aspects of science and technology in general and chemistry in particular. The explosion of industrial and technological developments in recent years has created analytical problems which demand increasingly sophisticated knowledge and instruments for their solution. So, and remember that this analytical chemistry is very important and in analyzing the the samples, the products, and also the intermediates. Sometimes many chemical reactions passes through intermediates, but how to know that the intermediates are formed is by using these analytical tools. For example, here you have suffered from disease, so and you are going to a medical and doing some blood test. This blood test has some values. These values the doctors will see and tell, okay, you are suffering from this or you are not suffering from this. This is called an analytical tool. So analytical tool is a method. There may be errors. There may be also some side errors. So this is because of the analytical chemistry you are going to. For example, any water, as you know, water is contaminated with many types of substances. So how to know that water is contaminated? Then you test the water. So the water can be tested by using various instruments. And these instruments give you data. These data are called analytical data. These data can be verified, and accordingly, you can have the thing. So the various instruments have been developed recently to measure this analytical data. Some instruments I have also discussed with you. So recent trends in analytical techniques have followed closely the development of new measuring instruments to find faster and convenient way for sensitive and selective determination of desired constituents. So, for example, you know nowadays different diseases have been coming out, and different types of instruments also come out. So, these new instruments will have the facility to to measure the various the techniques are there to measure the properties of the compounds, and these methods. So, therefore, research is going on to research is going on for these purposes. Hmm. Today, we have a number of instrumental methods which can be analyzed in minutes, what was done in days before this one. So, therefore, there have been three major contributions in the analytical chemistry. One is the flow of theory from physical chemistry and physics into analytical chemistry. So, in analytical chemistry nowadays, physical chemistry and physics, both this knowledge is required to study analytical study. organic chemistry. And next is the application of electronics. Nowadays, all the instruments we have seen are electronically measured. Means whatever you do, you get data electronically. So electronical application in analyzing this data is very important also. Next one is one more thing is computer. As you know, computer is also used for data processing. Whatever, wherever you go, for example, you are using, you are doing any chemical test in any research laboratory. You will see there will be a monitor, there will be a computer. So in computer, the data are being processed, and these computers are automated and control of instruments means once you put the sample inside the calibration tube, automatically the data will come out to the computer. So it is a totally computer monitored data processing center. This is a very important thing. Remember always that computer nowadays not a single machine is used by hand. It is now all are used mechanically or electronically, or all are used guided by computers. So computers are nowadays very important tool in in analyzing the samples by method of analytical chemistry. So summary. So in summary, I can just because 15 minutes left, I can summarize whatever I have discussed. In summary, that the general prospect we have discussed about the analytical chemistry is concerned with the detection, determination, and separation of substances. So in nutshell, analytical chemistry is concerned with detection, determination, and separation of substances. Substances. It deals with the development of methods for chemical analysis. Application of chemical analysis are to be found everywhere in scientific and industrialized society. Methods of chemical analysis developed at early stage are known as classical methods, while those developed mainly in the second half of the last century is known as modern method of analysis. Analytical methods can be classified into various ways according to criterion adapted. The major classifications are chemical classifications, electrical classifications, optical classifications, nuclear classifications, and separation methods. These methods can further be classified according to the quantity of being measured. Utility of analytical technique is to be found in various fields as the key to the solution of variety of scientific problems. So remember, whatever the things we are visualizing now in the modern days are because of the study of this analytical data through computers. The recent trend in analytical technique have followed closely the development of new measuring instruments to find faster and convenient way for sensitive and selective determination of desired constituents. Instruments can be designed that will automatically perform many or all the steps of analysis. So the nowadays instruments have been designed in such a way that whatever you can want, you can get from the machine data. This is very important things I am discussing it. Okay. Then in the data analysis, in summary, I can say that there will be errors. Remember always, whatever you determine, there will be an error. The reason for the errors can be assigned and hence can be corrected also. There is no missing word. There are two types of there are two terms. One is called accuracy, one is called precision. Questions will come. Accuracy and precision. So accuracy and precision are frequently used in evolution of analytical data. The accuracy tells the nearness to the true value, and precision tells the reproducibility of replicate determinants. The smaller the determinant error in the determination, the more accurate is the result considered to be. A result may be precise even without being accurate. On the other hand, a result cannot be accurate unless it is precise. So there are things you remember that always that when the result can be accurate unless it is precise. Precise means it may be accurate. Correct use of the significant figures, which is dependent on the application of various computational rules. So as you know that whenever you have calculate data, you may have 1.234 point, we can say 21.32561. So of decimal, you have so many digits are there. So you have to what you have to round up it. So rounding of these digits is very important, and this is done through scientific figures. The important the important computation of rules for correct use of scientific figures is discussed. Next one, the last one, I'm discussing the last chapter summary. So here we have discussed about the statistical analysis is necessary to understand the significance of an item. So statistical analysis is very important. Means mean, median, mode. As you know in statistics, the three important terms are used. One is mean, other one is median, other one is mode. So in this unit, we have studied the methods used by scientists in evaluating the significance of analytical data with the knowledge of normal distribution of errors in terms of probability. Replicate determinations should be made in order to approach the value of experimental means around the true mean with a certain degree of probability. So probability means how far the value are correct, how far the value are precise, how far the value are accurate. This depends on your analysis called statistical analysis. So this is done by measuring the median, the mode, the mean. All these are used instruments used to measure the statistical analysis. Okay. So the students. So we have this chapter is basically based on the things of analytical chemistry. So it is not at all related to chemistry. It is data analysis. How you collect the data analysis by different methods. So methods are there important, but the analytic part is methodical part. It is a computational part. From computer you can get a touch. Therefore, no need to be worried about it. But next chapter we will discuss in the next class, tomorrow class. Please, I'm asking all of you, please one help government from class 3, 4, 4, 4 to 4 class. Chandni, projects, I take class 2, 4. Hello, Chandni, Rajasmita, Rohit, Swapna, hello, hello, are you listening to me? Are you listening to me? Hello,
Voice is not clear, sir.
okay, okay. Now, uh, here or not? Hello, Now you can able to hear me?
Your voice is not
Yes, but
clear.
I'm
not clear,
asking.
sir.
Okay, I'm asking that tomorrow onwards, can I take class from? Hello, now it is audible to you. Now, okay.
Yes, sir.
Hello.
Yes,
Okay,
sir.
I'm asking all of you. As I'm in the government of Odisha, Department of Higher Education. So can I take class at the from 2 to 4 p.m.? No problem, na? Hello, hello. Can I take class from 2 to 4 p.m.? If you all agree, then I can take class from 2 to 4 p.m.
Sir, your voice is not audible, sir. Sir, please repeat.
Now it is audible. Now it is
Yes, yes,
audible.
sir. Yes, sir.
Can I take class from 2 to 4 p.m.? Launch break time. Hello, 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 hello. Can I
Yes,
take
sir.
class
Yes,
from
sir.
4? Can I take class from 2 to 4 p.m. tomorrow?
ये तो सबको पूछना पड़ेगा, सर.
हाँ, तो थोड़ा पूछ लें तो अच्छा रहता, क्योंकि मैं डिपार्टमेंट में काम कर रहा हूँ, तो थोड़ा मुझे मतलब
अच्छा.
टाइम में मैंने इवनिंग में प्रॉब्लम हो रहा है, तो शायद मैं 2 से 4 ले सकता हूँ। तो कल से तुम्हारा केमिस्ट्री का क्लास पड़ेगा। वो आज तो एनआरटी का केमिस्ट्री था ना।
हाँ, हाँ, सर.
तो कैसे सब बोलेंगे तो मैं कल ऐसे इस टाइम में ज्वाइन कर सकता हूँ। 2 बजे तक हो सकता है।
Sir, it would be better if you continue this timing, sir.
हाँ, हेलो।
Sir, can you continue this timing or any other timing 2 to 4? Will okay, sir.
I want 2 to 4 to continue.
Hello?
हाँ,
Sir, 2 to 4 only for tomorrow, yeah, other day also?
no, for all time 2 to 4 for all 5 days or 6 days remaining. If you all agree, then only. Otherwise, I'll take in
Sir,
the evening.
this, sir, it depends on all the people, all the
Yes,
students, sir.
yes, yes. Therefore, I'm writing on this. Acha, how many students have joined in this program? Total 12 or 13.
Sir, we don't know, sir.
But here I have seen only 13 or 14 students are there. Then how to communicate them? If you all present, then only you can say. Otherwise, it will be the same time or what? No. Okay. 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 Tomorrow we'll decide. Okay. Okay.
Okay, sir.
Tomorrow. So today class is going to be end. So tomorrow we'll decide. Okay.
Okay, sir.
Okay, sir.
Okay. Thank you. So tomorrow we'll decide. And after the class will end. Okay.
Okay,
Okay,
Thank
sir.
you.
sir.
Thank you.
Okay,
Thank you
sir.
very
Sir,
much.
thank
Thank
you,
you.
sir.
Thank
ये
you.
नहीं
you,
हो
sir.
Thank you, sir.
Thank you. Thank you very much. Thank you.
Thank you, sir.
Thank you.